Hello, Chem 110. This video is a follow-up to the video about how to calculate concentration, and this one is using concentration as a conversion factor. So in the last video, we had a solution that had sodium carbonate, Na2CO3, and we made a solution where that concentration was 0.150 molar. And we determined that that means, because of the mole ratio, that the concentration of sodium was 0.300 molar. So in this video, we're going to learn how to answer two questions. So here's one kind of question. We want to know how many mole of sodium plus are there in 12.0 milliliters of this solution. And problems like this require us to see that when we have a concentration given in a problem, that this is a conversion factor. And I encourage you, if you don't see this right away, or maybe if you do, to write it as a conversion factor. It looks just like a number here, but really what that means is we have 0.300 mole of sodium over 1 liter of solution. And that's a ratio or a conversion factor. We can use it as written or we can flip it. So if we go back to my question now, this is a dimensional analysis problem. This, oops, I meant to use the pen, not the eraser. So that was 12.0 milliliters. And this is my starting point. And you know what to do with a starting point and conversion factors. This is the end point we want to get to. So we'll start with 12 milliliters. When we're using concentration and molarity, we need to convert milliliters to liters. So this is one way to do it. And then we use our conversion factor. And we want to get rid of liters, so we leave liters on the bottom. That gives us moles of sodium plus on the top. And if we go through and do this, our milliliters will cancel, all liters will cancel, and we have moles of sodium left, which is what we wanted to get. And if we multiply this through, we get 0.0036 actually not, yes, 360 moles of sodium plus, and I was careful to keep my 3 sig figs in that answer. All right, so that's one way to use concentration. You have a number of milliliters or a volume of the solution. You want to calculate how many moles are there. And then the other kind of question is basically just the reverse of that. So how many milliliters of this solution do I need if I want, say, 0.045 moles of sodium? Okay, so this is again a dimensional analysis problem. This is my starting point. And now I want to get to milliliters of solution as my endpoint. So I'll start with my starting point. I want 0.045 moles of sodium plus, and I use my conversion factor. Now this time I want to get rid of moles, so I put moles of sodium plus on the bottom and liters on the top. And if I want it in milliliters, I'll need to remember to change to that. And when I do this, I note that I'm going to have 2 sig figs in my answer. I get the answer 150 milliliters. Okay, so I'll give you one practice problem here, and you can stop the video and try it. So here's a practice problem. We have a solution which has sodium in it. It must have some counter ion, but apparently I don't care about that for this problem. The concentration of sodium is 0.032 molar. So first of all, I want to know how many moles of sodium are there in 9.8 milliliters of that solution. And number two, I want to ask how many milliliters do I need to get 1 times 10 to the minus 4 moles of sodium. Okay, so you can stop the video and try those and then come back and see my answer. So number one, I'm going to start by reminding us that this means I have 0.032 moles, and I just kept sodium plus the same as we had in the last problem. It would be whatever the solution was, but that's our conversion factor. Okay, so for number one, I have 9.8 milliliters. I'm going to change that to liters and then multiply it by the concentration with moles on top because I want to end up with moles. And when I do that, I get 3.1, 2 sig figs times 10 to the minus 4 moles of sodium. For question 2, my starting point is now 1 times 10 to the minus 4 moles of sodium plus. I now flip my conversion factor. For every liter of solution, I have 0.032 moles of sodium plus, and because the problem asked for milliliters, I do need to convert like this. And when I do this, I get an answer, which is 3.1 milliliters of solution.